class. So I had given homework in that balancing back exercise, question number 5, 6 and 7. So one or two have asked the doubt and so I'm thinking that all of you, it is clear, for all of you it is clear. So let's start the new topic, and the new topic is, after that we have done till decomposition reaction, okay, and all the types of decomposition reaction also we have done. So now the next type is displacement reaction. Got it? So displacement reaction is the C type. Let me what was the type number it is given? 2, so 3. I'm writing 3 over here. This is displacement reaction. As the name suggests, displacement, that means the one is going to be displaced by the another. Got it? The one is replaced by other. So who will displace the and who will be displaced? So obviously displacement reaction is the reaction in which higher reactive elements displaces the less reactive element from its solution. Okay, so you must know this thing. Higher reactive element will displace whom? Less reactive element. Got it? So that is called displacement reaction. So in this there is an activity. Let's start with this activity and then I will explain all the types of this. Displacement reaction activity 1.9. It says that take 3 iron nails and clean them by rubbing with the sandpaper. Take 2 test tubes marked as A and B. In each test tube, take about 10 ml copper sulfate solution. Okay, let's start with this activity. Activity 1.9. It says that take 2 beaker or 2 test tube with the copper sulfate solution, CuSO4 in both case. Okay, and 10 ml we have taken. The 2 iron nail with the thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. If this is A and this is B, I'm just with the help of thread, this iron nail is dipped in this, okay, for 20 minutes. Next is says that keep 1 iron nail aside for comparison. The third iron nail, just keep it aside, okay. Then after 20 minutes, take out the iron nails from the copper sulfate solution and compare with these. Take it out after 20 minutes and compare with this. What will happen to this iron nail? So I will tell you the observation afterwards. Okay, next is compare the intensity of the blue color of the copper sulfate. This copper sulfate is blue in color. Okay, so you have to check what is the color change. Also compare the color of the iron nail dipped in the copper sulfate solution with the one kept aside. You have to check that what is the difference between these 2 iron nails, which is dipped in that and which one is not dipped in the copper sulfate solution. Got it? So let me explain this. So this activity 1.9 can be explained in form of reaction that Fe, iron nail, when it is dipped with copper sulfate solution, this copper sulfate is intense blue color. Got it? When it is dipped in this, what happens after some time? This Fe will displace the copper from its solution, FeSO4 and plus copper. Got it? So this copper is brown in color and that will deposit on the iron nail. That is brown in color and will deposit on iron nail. Okay, on iron nail. and this becomes FeSO4. So what will be the color change? This is intense blue color, and once this reaction will happen, the color of this FeSO4 will convert into green. Okay, so the question is that three things. One is copper sulfate solution where we have not dipped anything, so you just check the color. The color is blue, dark blue. Yes, intense blue, not say dark blue. When we add this nail in this copper sulfate for 20 minutes, afterwards when we take out and we have just compared these two iron nail, we saw that we can observe that the iron nail which is dipped in the copper sulfate solution has a brown deposition on it. Okay, so the color, the original color has been changed. Done. And the color of the copper sulfate solution, this was blue, and the one in which the iron nail was dipped, now it is converted into green color. Got it? So this can be the observation. What is the observation? First observation, the color of the solution will be converted into blue to green. And second observation, the iron nail will have a brown deposition of copper. Got it? This is the reaction. So what is the thing that why Fe displays this? What will happen in just 1 minute? If what will happen if this copper nail is dipped in FeSO4 solution? Will there be change in color where there will be some deposition? No, no reaction. Got it? Can you tell me why? For this you have to learn a T series. This is काशी नाथ के महंगे आलू जरा फीके पके. Got it? In this way you can learn. And then hydrogen is there. After that hydrogen, the coinage metal. The coinage metal, that means which is used to make coin. Okay, the coinage element which is very cheaper. So that is copper. More like costly than copper is silver, and the most costly one is gold. And at last we will write Pt. So this is the reactivity series which is commonly used for your reactions. Okay, in your reactions, this is called reactivity series. So I just tell you the form, the way by which we can learn. You can use another way also. Okay. So the one which is above is more reactive than the lower one, and the upper one can displace the lower one from its solution. Got it? Try to understand. The upper one element is more reactive than the lower one element, and hence the upper one element can replace the lower one element from its solution. So just check Fe and Cu position. Fe is here and copper is here. So Fe is more reactive than the copper. Got it? So that's why Fe can displace the copper from its solution, and that is happened here. Okay, Fe is more reactive than the copper, so Fe will displace the copper from its solution and will take its place to form FeSO4 and copper. In this reaction, why it is no reaction? Because copper is less reactive. Copper is less reactive than Fe. Okay, so Fe is more reactive, hence it cannot be displaced by copper. Isn't it? I think it's clear. Okay, in this you have to study 3 types of displacement. That the classification of displacement reaction. Classification of displacement reaction. The first one is metal-metal displacement. Metal-metal displacement reaction. That means displacement reaction. That means the more reactive metal means more reactive metal will displace the less reactive metal. Got it? As for example we have done, the above one is also an example of this. Another example we can take, like what will happen if zinc is added to this is FeSO4 solution. What will happen? Well, this displacement will be there. Displacement will be there. Yes, this displacement will be there. Why? Because zinc is more reactive than the Fe. Zinc is upper than the Fe. So it will displace and it will form this. Got it? Another example, if I'm asking, what will happen if copper is added to magnesium sulfate solution? Again, there will be no reaction. Why? Because copper is here and magnesium is here. So copper cannot displace magnesium. Yes, of course, agar this reaction was like Mg plus CuSO4, so this reaction could have happened. Yes, got it? So this is metal-metal displacement. In this, what happened? More reactive metal will displace the less reactive metal. Okay. Next is metal non-metal displacement. It says that metal will displace non-metals from its solution. Got it? From its solution. So as for example, what happens when zinc reacts with HCl, aqueous HCl, not in gaseous form, okay, HCl. So check, zinc is here and hydrogen is here. So that means zinc is more reactive than the hydrogen, isn't it? So this will displace. So what will happen? So we know that Zn has +2 charge, so this will form compound ZnCl2, not ZnCl, okay? And then this will liberate in form of H2. So to make it balance, we have to add 2 over here. Got it? Clear? So question is there, if suppose that copper plus HNO3 I am doing aqueous, will there be any reaction? Again, no reaction. Can you tell me why? Because see, hydrogen is here and copper is here. So copper is even less reactive than the hydrogen also. So that means it cannot displace. Got it? But if we do the reaction with Mg plus HNO3, will there be any reaction? Mg is here and H is here. Yes, it can displace and it will form MgNO3 whole twice, as magnesium has 2 valency and this H2. Okay, I'm using aqueous here. There is some reactions that I will explain later on. Okay, so here H2 gas, it will liberate. Any doubt in this? Okay, and the third one is non-metal displacement. Again, as the above case, metal one. In the metal displacement reaction, what was that? More reactive metal will displace the less reactive metal. Here what we will write? More reactive non-metal will displace the less reactive non-metal. Okay. Example, if we do this F2 plus KCl. So fluorine is more reactive than the chlorine. So that's why what it will do, it will take its place, KF, and Cl2 will liberate out. Got it? How can you say that it is? So there is a 17th group. That group we have to study in chapter 5. Till now you just learn it. That is, two groups are there. One is 16th group and another is 17th group. 16th group is very easy to learn. It is usse tepo. Got it? Usse tepo. The upper one is more reactive than the lower one. Clear? And 17 is FCl Br I 80 is radioactive. Don't. This is Faltu class boring instructor I. Got it? So it is like that. So you can learn it. There are so many ways to learn it. Any way you can use. Okay. So the upper one is more reactive than the lower one. So that's why F is more reactive than the chlorine. So F has replaced that. Got it? And one more thing you have to keep in your mind, these are in form of exist in form of gas. So they will never be written as F or Cl or something like okay. It will always exist in form of diatomic. Diatomic means F2, Cl2, O2, like this. Are you getting it? Okay. So what will happen if this Br2 reacts with KCl? Will there be any reaction? Will there be any reaction? No, there will be no reaction. Why? Because bromine is lower than the chlorine. And chlorine is more reactive than the bromine. So here again, what will write? No reaction. So this is the type of the displacement reaction. And in this, related with this displacement reaction, one thing, in text question 1 and 2, page number I think 9 or 10 it is, in text question. It is left, so you are supposed to do in text question 1 and 2. Page number 9 or 10 it is. I'm not sure. Let me check that. This is page number 10. Okay. Page number 10. In text question 1 and 2 you have to practice. You have to do it in your fair notebook. Okay. So next we will do, let me mark it as A, B and C, not 1, 2, 3. Third is displacement reaction. Okay. So next is double displacement reaction. So the next reaction is after displacement reaction. Next reaction, fourth is double displacement reaction. Double displacement reaction. Okay. As the name suggests, double displacement. That means displacement will be there, but it will be now twice, double. Okay. So this is also called as can be defined as that the mutual exchange of ions. The reaction in which there is a mutual exchange of ions between two compounds. Okay. Mutual exchange of ions between two compounds is known as double displacement reaction. Got it? So let's take an example for this. Example, if we like HCl plus NaOH, if we do. So see here with H this is Cl and here with Na this is OH. So now what we'll do with this Na, I will do this negative part NaCl, and with this positive part I will take its negative part and will make this. You can explain, like I can explain it in other way. Suppose that one is AB, A1, B1, okay, and another is A2, B2, okay. So what we will do, you have to be careful about this. The one which is written afterwards is always carrying negative charge, and the one which is written first is always carrying positive charge. So we have to make a compound with the positive and the negative. Oh, got it? So this one A1 is positive here. So if there is exchange, it will attach with this B2. Got it? Similarly, if this positive A2 is reacting, so it will attach with its negative part, yani B1. If you will write A1 B A2 or B1 B2, it will be completely wrong. Got it? it is always like this. So be keep this thing in your mind. Okay, so that's the same thing I have done. This is the positive part, then this positive part is going to attach with this negative NaCl, and here the positive part is going to attach with this negative part H2O. Okay, another example, if we take like AgNO3, okay, plus BaCl2. If I'm taking another example, what will happen? Its positive Ag is going to attach with its negative, that is Cl. So Ag valency is 1, so it will be only Cl, not Cl2. Got it? In this next case, it will be Ba positive part, and then the negative part of this NO3 whole twice. So why I have done twice over here? Because barium has charge +2. That you have to learn. Okay, and might be in class 9th it is like explained. Okay, so this is like, so now here there are the two equations I have written. Both the equations comes under double displacement reaction. But if we classify it properly, if we go in depth, this displacement reaction also has two parts. Okay, one is precipitation reaction. Precipitation reaction. You can say types of double displacement. Okay, reaction. So this is one is precipitation reaction. Precipitation reaction here, that is how you will define it. Such double displacement reaction, such double displacement reaction where a precipitate is formed. Precipitate is formed as one of the product. Okay, that means in this product one compound will be there as a precipitate. Got it? So example we will do later on. Second part is neutralization reaction. Neutralization reaction. How you can define it? Such double displacement reaction where neutralization occurs. Neutralization when it will occur, that means the reaction between acid and base. Reaction between acid and base. Got it? So if we want to classify these two examples in these two categories, so this is acid and this one is base. So this reaction is an example of neutralization reaction. Got it? Neutralization reaction. And if we check this equation, here it is AgCl white PPT is formed. So this is called precipitation reaction. Now you can ask how we will identify this is precipitate or not. So here I am giving you a trick. You have to just learn it. The compound having few elements always form a if it is in the product side, it is always in the precipitate form. Are you getting it? Some compounds like Ag compound, Pb compound, then Ba compound, and not always Ba. One second, and then the most important AgPb, and that's it. Okay, I will tell you if a few will be there. I will tell you. This is the example. If this is these compounds, if the compounds of these elements, okay, are there in the product side, and if we talk about the Ba is very particular with this BaSO4. Got it? So if the compound of Ag, Pb, BaSO4, like it is there in the product side, then it will form what? Precipitate. So there as a compound like AgCl, it will give you white precipitate. If it is AgBr, these are the things that I'm not writing in the notes. So you people are supposed to write it in short note form with the help of these compounds. If the compounds of these elements, okay, are there in the product side, and if we talk about the BA is very particular with this BaSO4. Got it? So if the compound of Ag, Pb, BaSO4, like it is there in the product side, then it will form what? Precipitate. So there as a compound like AgCl, it will give you white precipitate. If it is AgBr, these are the things that I'm not writing in the notes. So you people are supposed to write it in short note form with the help of this video. Okay. So AgCl is white PPT, AgBr is yellow PPT. Okay. Pb like SO4, if it forms, it will be white PPT, and if PbI2 forms, it will be yellow PPT. BaSO4 is again white PPT. Got it? So these are the things that by this way you can identify whether it is precipitate or not. Got it? And you have to keep in your mind the first group element. First group element is first and second group element. First group element, I'm telling you, है लीना की रब से फरियाद. Out of that, you don't have to learn this. These are we will do in next class. Okay. So you have to learn this is first group, है लीना की रब से, ठीक है, फरियाद. And the second group is बेटा मांगे कार स्कूटर आप राजी. That again the three you don't have to learn right now, only these. So first and second group elements, if these elements are there as a compound in any site, it won't exist in precipitate. That means they never form precipitate. Got it? What I said? They never form precipitate. They form soluble compound. So precipitate nahi banega. Now you can ask, precipitate hota kya hai? Precipitate is a curdy substance which is insoluble. Like it is not soluble in water. It is insoluble, and when this reaction happens, it settles down at the bottom. So that is called precipitation. Precipitate. Got it? Precipitate is an insoluble curdy substance which settles at the bottom. So that is precipitation reaction. So if we write this is the example of. Another example also you can do, like in your NCERT, another example like Na2SO4. This is see Na2SO4. If it reacts with BaCl2, okay, BaCl2. So this will form again the positive part of this, negative part of this. So NaCl, we know that sodium has +1 charge, so it will form NaCl. Okay. To make it balance, 2Na2Cl, so write it here. And next is positive of this Ba and the negative of this SO4. Though both have +2 -2 charge, so it again negligible. So which one is precipitate over here? Right now I have said that this compound won't form precipitate, and at the same time I said these compound BaSO4 like this compound, they form precipitate. Got it? So this is the precipitate. What color? Right now only I explained BaSO4 is white precipitate. Got it? So this is an example of precipitation reaction. Now the neutralization reaction. Neutralization reaction is where the acid and base react with each other. Like another example, this one example is given. Another example you can take any acid, like HNO3 is an acid, any base like KOH is a base. So I'm making this positive of this K, negative of this NO3. Again, the positive of this H and the negative of OH, this is H2O. So this won't be precipitate because we can see first group element never forms precipitate. So this is an example of neutralization reaction. I hope it is clear. So this is an example of double displacement reaction, the two types. Next, there is an activity 1.10. Activity 1.10. What it is, let me read out. Take about 3 ml of sodium sulfate solution in a test tube. In another test tube, take about 3 ml of barium chloride. Okay. Mix the two solution. What do you observe? The same thing which we have done here. Okay. In that, at one beaker, this is Na2SO4. Another beaker, this is BaCl2. What will happen if these two are added? So this will form NaCl plus BaSO4. Okay, and this BaSO4 as a precipitate will settle down at the bottom as a Kurdi substance, and NaCl will remain soluble, so won't be visible. Got it? So you can say, what will be the observation? There will be after this reaction, there will be white Kurdi substance, which is insoluble substance. We can write in the bracket insoluble. Since it is insoluble, that's why it's settled down at the bottom. If it is soluble, it will be dissolved. Got it? So white Kurdi substance insoluble is settled at the bottom. Got it? That is known as precipitate. Okay, got it, class? So this is the double displacement reaction. Again, next reaction is very important reaction. So we'll do in next next period. Okay. By the time I'm giving you some homework related to this topic only. One I have already given that in text question. Now that back exercise questions. Okay. So in the back exercise question, you are supposed to do back exercise. This is 1.1 to 1.4 you have to do. Got it? And next you have to do question number 9, 10 and 11. Got it? So these are the questions, that is homework, and you people are supposed to do it in your classwork notebook. So one day I can ask for the complete notebook, so you have to show. So that's why I'm saying do it side by side, do it on the regular basis, don't accumulate the work. Okay. So class, thank you for today. Thank you.